Oh, okay, we're recording. So, what we're going to be doing this chapter is we are going to be graphing logarithms. Okay? Logs are an inverse of exponential functions. So what I'm going to do to kind of introduce us into our log graphs, I'm going to do a little review on exponentials. Okay? If you remember, this is a topic from Math 1, so it's been a minute. But our exponential function started out as a to the x. Okay? A is going to be any number that is greater than 0 but is not 1. All right? So a has to be greater than 0. That's going to be important as we move into logarithms. And a cannot equal 1. The reason why there is 1 to any exponent is 1. So it doesn't count as an exponential. It doesn't grow exponentially. Okay? So, for starters, I'm just going to go ahead and we're going to dive in with an example of an exponential. So, we'll just say 2x. So, we already know, or rewriting logs, we kind of know that relationship. If not, we'll get there. So, 2 is our base. Then we have our exponent and our solution of y. So just kind of some vocab checkups there. So y equals 2 to the x. What I'm going to do is I'm going to graph this so I can go ahead and show you its inverse, its log graph. So we're going to start with a table of values. So I'm going to go ahead and we're going to plug in -2, -1, 0, 1, and 2. A couple of these are easy, like if I plug in 2, that's going to go ahead and give me 2 squared, which is 4. That's simple. So that gives me the point 2, 4. Then if I plug in 1, this gives me 2 to the first, which is 2. Again, simple. So I plug in 1 when x is 1, y is 2. What happens if I plug in 0? Okay, if you remember this, anything raised to the 0 power is 1. Okay? So plug in 0, I get 1. Plug in -1, so this is 2 to the negative first. When it's a -1, remember negative exponents drop to the denominator, so in this case I get 1 over 2. Okay, so -1, I get 1/2. Notice it's a positive 1/2. 2 to the -1 becomes 1 over 2 to the first power. -2, that's going to drop and it's becoming 1 over 2 squared. And 2 squared gives me 4. Again, it's a positive value, which is important to know, and it's in the denominator. So 1 over 2 squared, so we get 1/4. And I get a graph that looks like this. Okay, so this is my exponential function. And we know the domain, I guess I'll write that out for you. The domain here, what x values can I plug in? This graph's going to continue to the left and to the right for infinity, right? So my domain here, x is all real numbers. It's anything. I can plug in whatever I want. And then my range is my y values. And if we look at our graph, remember how I kept emphasizing these were positive? That's because they're above the x-axis. Those are positive values. Is there any number I can plug in for x that would make 2 to the exponent equal 0? The answer there is no. 2 times itself, how many times, will never equal 0. So our y is always going to be above that x-axis unless we move it, right? Transformations. So our domain, I can plug in anything I want. Range has to be greater than 0. All right, for my inverse of my exponential is my logarithm. Okay, logs help us solve for exponents. Exponents help us solve with logs. They are inverses. Remember from our inverse chapter, to graph an inverse, we take the x and y of the coordinates and we switch places. So my point here of 2, 4 is going to become 4, 2. Just switching that order. All right, and then I have 1, 2 becomes 2, 1. 0, 1 becomes 1, 0. Negative 1, 1/2 becomes 1/2 negative 1. And negative 2, 1/4 becomes 1/4 negative 2. And I get my logarithm. So remember, with those inverses, we see a reflection across the line, y equals x. So we see it be flipped, and we get our log. This is log base 2 of x. The base stays the same, and the x's and y's kind of switch to become that inverse. Base 2. All right. So the relationship here, the domain and range, also switch. Remember those x's and y's, and we can see it in our picture. Our domain here, what x values can I plug in? I can't go beyond here. Because remember, our log is solving for our exponents, and log equaling exponent, and there's nothing I can plug in here that'll give me that 0. So our x has to be greater than 0. Our outputs here were never negative, never 0, so my inputs have that same relationship. And for our range, this graph's going to keep growing and keep declining here, positive infinity and negative infinity, so my range will always be all real numbers. Okay, so with this, we started out with that inverse information. We started with the exponential, graphed its inverse, we ended up with our log. We don't always want to do that. We want to just be able to graph our log. So there's a couple key points that'll help us do that. The first one is this point here of 1, 0. Okay, and the reason why is because of this relationship. Anything raised to the 0 power is 1. So if I reverse that and I plug in 1, that's telling me log base 2 of 1. 2 to what power is 1? That's 0. No matter what my base is, if I plug in 1, it's going to equal 0. So we're always going to have this key point. The second point that I like, I'm going to call this point A1. Not like the steak sauce, but logarithm. A1. So in this case, A is referring to our base, like we saw over here. So here my base is 2. So log base 2 of 2. That's saying 2 to what power is 2. No matter what the base is, if I plug that same number into my log, it will always equal 1. So these 2 points are going to come into play as we extend our graphing logs with transformations. So come back, check out my next video.